This is our 5.3 day 3 notes for Algebra 2. I have the notes kind of showing. I cut off the top so that we would have a little bit more room on here. But it says at the very top, a radical expression is considered simplified if there are no perfect squares left inside the radical and there are no radicals in the denominator. Same thing as 5.3 day 2 notes. But we have this added part right here, because if you look at the denominators in all 4 of the examples on your notes, when there is more than one term in the denominator, we're going to have to multiply the numerator and denominator by something called the conjugate. The conjugate is going to be the same exact thing in the denominator, but with an opposite side sign that connects the 2 terms in the denominator. So I'm just going to start with this example. I'm going to take the long way and show you how you can do a shortcut. So bear with me, the first one's going to take a little longer while I explain it a little more. So in the first one, we can't just multiply top and bottom by root 3 like we were doing on the day 2 notes, because then we'd have 5 root 3 when we distributed, and we'd still have a root in the denominator. So we actually need to multiply top and bottom by 5 minus the square root of 3. See how we call this the conjugate. It's the same exact thing as is in the denominator, but we change the sign to a minus sign. So we need to do that in the numerator and the denominator. In the numerator, I just have to distribute that 2, so it's not too bad. 2 times 5 is 10. And then I have my minus sign. 2 times root 3 is 2 root 3. Now in the denominator, this is the part that's going to take a little longer this time, but we'll cut it out next time. So when you multiply 2 things together that have addition or subtraction, then we can't just do 5 times 5 and root 3 times root 3. It doesn't work that way. We have to really distribute by FOILing. So we have to do first, outer, inner, last. So the first, 5 times 5, we get 25. For the outer, 5 times negative square root 3, we have minus 5 root 3. For the inner, we have positive 5 times root 3, so that's plus 5 root 3. And for our last, we have root 3 times negative root 3. Remember that a root times a root is like saying a root squared. So I'm going to keep positive times negative as negative, but root 3 times root 3 is just plain old 3, because root 3 squared gets rid of that root sign. Now the key here, and this is how it's always going to work when you multiply by a conjugate, is that these middle terms that still have roots on them, when you add them together, they cancel each other out. So really secretly, when you do this, you'll be able to just do the first times the last, because you know the outer and inner will cancel. So that'll be the shortcut we take from here on out. So if we would have taken the shortcut, we would have had 10 minus 2 root 3 over 25 minus 3. 25 minus 3 is 22. Now you do have to check to see if you can simplify. You need to check all 3 regular numbers. Do not worry about under the root. So 10, 2, and 22, if they share a common factor, you can simplify. And in this case, they do share a common factor, and that factor is 2. So I can divide each piece by 2. 10 divided by 2 is 5. 2 divided by 2 is 1, but you don't really have to put a 1 in front of that root 3. You could if you wanted to. And 22 divided by 2 is 11. So I seriously just divided each piece by 2 to reduce, and that is my answer. So for example 2, maybe it'll go a little quicker. We can take a shortcut. I need to multiply by the conjugate, which is, so I have to close that in parentheses, root 3 plus 4. That's what I'm multiplying this time. Same thing, but I changed the sign in the middle. You do not change any other sign besides the sign that connects them. So root 3 plus 4. In the numerator, when I do this, 1 times root 3 is root 3 plus 4. So that was just me distributing the 1, makes it stay the same. Now that's over. When I do this, remember, I can just do the first and the last because the outer and inner should cancel if you set it up right. If you're not confident you set it up right, you might want to do all the steps. But root 3 times root 3, that's just plain old 3. Because a root times a root gets rid of the root. And then negative 4 times positive 4 is negative 16. So this is going to be equal to root 3 plus 4 over negative 13. Now you could leave it like that. It might look a little nicer if instead you bring the negative out front. So if instead, I'm going to erase this to save me a little room. If instead I wrote it, so I'm going to put my equal sign right there. If I just bring the negative sign out front, then I don't have to have the negative sign in the denominator, and that might look a little bit nicer, and that would probably be an answer you would see on a test rather than having a negative in the denominator. It's kind of improper. Now I'm circling it because I'm done, because there's nothing else I can do. So that negative's out front. It's not just on the negative 3, it's out in front, just FYI. I'm going to do a second video for the next 2 examples.